All right. So welcome to the lecture on Introduction to Computer Networks, Part 1. So the topics that we will cover in this presentation are going to be on the different types of computer communication methods that we have to give you a general overview, followed by the networking devices which are there to enable the different forms of network communication. Going forward, we'll also cover the different forms of computer media, the different forms of cables and connectors that we use to set up computer networks. Following that, we will have a quick overview of uh, the basic understanding of what network protocols are, followed by the different kinds of computer networks which are there to facilitate different forms of architecture and use cases. For example, for home uses, for enterprise uses, universities and other institutions, they require different form of structures of the network, and they're defined by different architectures. So those are things which we will use, which we will cover in the computer network section. So what are computers and computer networking particularly? So a computer is basically a device that processes, thinks, and modifies computer bits. Receives, thinks, modifies, stores, sends computer bits, and bits are basically zeros and ones uh, in streams of data. On the other hand, a computer network is basically the mechanism by which two or more computers can send and receive data in the form of zeros and ones. So if we have a bunch of devices which are connected, so let's say we have PC1, we have PC2, we have server, and each of these entities can communicate with each other by transferring binary bits in the form of zeros and ones. So to understand how computers communicate, we first need to understand what we understand as computer data. So computers only understand zeros and ones, which is basically the basis of the binary number system. The term binary means it only has the choice of two. That means 0 or 1. So the data representation, any form of data that a computer understands, is based on binary digits, which are again zeros and ones. The smallest unit of the data that a computer can understand is something that we call a bit, that is a single 0 or 1. However, there are multiple different units a computer can understand. So if you look here at the table here, a bit is only a 0 or 1. A nibble, on the other hand, is a collection of 4 bits. A byte is 8 bits, a word 16, and a double word is 32 bits. So what it means is that if we have, let's say, a computer understanding a stream of data, and it is coming into the PC in the form of a stream, with multiple binary bits. So let's say 0 1 0 0 1 1 0 0 1 1 and so on and so forth. So this is a stream which is coming in into the computer. So this individual 0 or this individual 1, this is a single bit. If we have basically a group of 4 bits, we refer to this as a nibble. Similarly, if we have 1, 2, 3, 4, 5, 6, 7, 8 bits in a group, this is what we call as a byte. This is probably the most common unit of computer data that we use. That is a byte, which is equals to 8 bits. So a word and double word similarly is 16 and 32 bits. So now we understand what a computer would basically interpret as data. But how do we represent the data? First of all, again, we have to emphasize the fact that any form of data is represented using binary bits, but we generally use groups of binary bits in the form of bytes. Examples of computer data may include decimal numbers, which are basically the numbers that we use every day, starting from 0 till 9, the basic numerical digits. It could be alphabets, uppercase and lowercase characters from A to Z, or special characters such as a question mark, an exclamation mark, a comma, etc. So all of these are represented in the form of binary bits. However, the representation of each of these type of data varies in the way they're interpreted. So when we are dealing with decimal numbers, they're represented by their equivalent binary value. So how does this work? This is going to be covered in the upcoming chapter, but to understand the basic understanding, when we have any number represented by the decimal numerical system, we refer to it between 0 to 9, and we write a small 10 here, which says that this is a base 10 number. If we have a binary, we have only options. The only options we have are zeros and ones, and this is a base 2 number. So you write a small 2 over here. And the number system from base 10 to base 2, there are different ways that we can convert it from a base 10 into base 2 or from base 2 to base 10. We'll look at it again in the upcoming chapter, but to understand how we represent numbers, this is what happens when we are representing decimal numbers. So that is pretty straightforward. If you want to represent something between 0 and 9, you just convert it into binary value, and that is going to be your data. But what happens when you are trying to represent alphabets or special characters? For this, we have what we call character sets. The most common character set that we use today is called the ASCII. And for ASCII, so this is our ASCII, the simplest ASCII reference table. What happens in ASCII is that it is a guideline of how you can represent characters as well as special characters in the form of binary. And if you look here, they define a binary number, which can also be converted into a decimal number, because we already have seen that all binary can be converted into an equivalent decimal, and the other way as well. So the character set in ASCII defines all of these characters and their equivalent binary representations. So let's say if you would like to write a B, this would be equivalent in binary as 1 0 0 0 0 0 1, and then B, this is 1 0 0 0 0 1 0. So the text AB is equivalent to the binary string, which looks like this. So next we try to understand the basic idea behind computer networking. Let's look at the common example that we use every day, an email application, right? So what happens here is that a user, let's say Bob, is trying to send an email to his friend Alice in some other part of the world. So Bob on his computer has something that we call a user agent. This is the same as a web browser. It could be your Outlook email or some desktop client that you have to send and receive emails. So Bob uses the user agent to write the email and sends it out. The SMTP is short for Simple Mail Transfer Protocol. So this is the process by which a computer understands that Bob is trying to send an email to Alice. So first the email is forwarded to Bob's mail server. The mail server, again, is another computer which is running the SMTP service and receives the email. And when it looks at the email, it sees that Bob is trying to send the email to Alice, who is, for example, on Yahoo. So Bob's email server, which in this example is Gmail, finds Yahoo and then forwards the email using the SMTP protocol to Alice's mail server, which is on Yahoo. After that, Alice doesn't really know yet that she has an email waiting on the mail server at Yahoo. So there are two other protocols commonly used, the POP3, which is the Post Office Protocol version 3, and IMAP, which is the Internet Message Access Protocol. So using these two protocols, the mail server notifies that, hey, Alice, I am your mail server, and you have a mail waiting on my server from Bob, who is with the Gmail mail server. So next, Alice's user agent, which is again the web browser or a desktop client such as Outlook email, retrieves the email, and then Alice is able to read the email. So this whole process requires a complex communication of various entities and different protocols to send the email from Bob to Alice using multiple different servers on the internet. Let's look at another common example, digital audio and video. You can think of a common application as YouTube, or let's say an audio streaming application, a podcast that you have installed on your smartphone, anything where you are able to access audio and video over the internet. So the internet is basically allowing you to perform computer networking and allows you to access audio and video. So audio, initially when we are talking into the microphone, this is a form of data in the analog world, and it needs to be converted into a digital representation because, again, we know that computers only understand binary bit. So the analog audio needs to be converted into a digital bit representation. We call this an analog to digital conversion. On the other hand, a video is basically a collection of digital images. And the feeling of a moving object that you get while watching a video is basically this collection of digital images which are played rapidly one after another. So to a human eye, it looks like a moving object. So for network applications which use digital audio and video, a concept that is commonly used is data compression. And the reason why we use it is because data compression allows us to reduce the file sizes for audio and video. However, when you reduce the size, you are also sacrificing some of the quality. So, to summarize, basically the higher the compression rate, the longer it takes to compress the file, and the smaller is the file size. And following that, the smaller the file size, your internet allows you to download it faster. However, the quality of the audio and video is reduced. So what is the internet? The internet is nothing but just a huge collection of interconnected devices and networks. So the image here shows a very simplified form of the internet where you can see different local networks being connected to each other, and they have many different kinds of devices. So you have home computers here, you have laptops, you have phones, you have servers, and all of these are connected through complex computer networking mechanisms. So these millions of devices are connected to function together as what we call the internet. The certain terminologies that you need to be aware of are terminal devices, something that we refer to as the end user systems, such as the PCs, laptops, smartphones, anything that you use to access the network. So it's basically in the hand of the users who are accessing the internet. Servers are, again, computers, but they are much high performing computers, and they are responsible for hosting contents on the internet. So when we say that a server hosts contents, it basically means that it allows you to access contents when you are part of a network. So let's say you were here, and then the internet is something to which you are connected, and on the internet there is a server. So when you're trying to access a web page, so you type in www. whatever, and your terminal device sends a request to the internet, and then your request goes through multiple different devices and finds the particular server that you are trying to access using the web URL. The server stores files, and when you're trying to access that particular website, it is actually a specific file that you're asking for. So the server then looks for it, finds it, and then sends it over through the internet across a complex network of devices into your machine, and then you are able to look at the web page on your browser, the contents of that web page. So to allow this complex connection of terminals and servers, we have in place what we call networking devices, such as hubs, switches, routers, and these devices are dedicated computing units which creates the physical connections from the terminals to the servers. And these connections are called communication links, and they could be different types. It could be optical fibers, copper wires, radio signals, satellite, wireless, and the rate at which you can access the data is defined by the bandwidth of each of these types of communication links. In other words, optical fiber has a specific bandwidth, copper wire has a specific bandwidth, radio frequency signals has a specific bandwidth, satellite connections has a specific bandwidth, and each of these different bandwidth limitations define how fast or how slow you're able to access the contents on the internet.